Yes, dear friend, good morning. Till now, I told you about radiations, the mode of transfer of energy, radiation, transfer energy without medium, and who can the heat energy? Infrared radiation, whose wavelength vary from 7,000 angstrom to few millimeters. In fact, these infrared radiation are electromagnetic waves. I told you about emissive power of a body and I told you that emissive power of any body at a given temperature is defined as the amount of energy, heat energy or radiant energy. You can say total energy, not only heat, all type of energy at any temperature, visible, infrared, or ultraviolet, like sun. But we can't heat anybody here on our surface to a temperature of sun. So only it can, any hot body here can emit light and heat radiation like filament bulb. When you pass current, it produces heat and light both. That total amount of energy radiated is called radiant energy. So amount of energy radiated per area per time at a given wavelength range is called spectral radiancy or spectral emissive power. Similarly, I told you now if E lambda is the emissive power at wavelength lambda, range lambda to lambda plus delta lambda, then amount of energy radiated by body in this range, that Q will be E lambda into delta lambda. Try to understand this what I am saying. Amount of energy, if E lambda is the spectral emissive power within range of lambda and lambda plus d lambda, then energy emitted within this range Q will be E lambda into delta lambda. Lambda is the wavelength of radiation being emitted by body at that temperature. Similarly, absorptive power, the amount of heat or radiation absorbed by a body is called absorptive power. If the A lambda is the absorptive power for a particular wavelength range lambda to delta lambda, so energy absorbed that Q VQ कह सकते हैं आप will be A delta Q A lambda into delta lambda. Absorptive power. I told you that when radiation fall on surface of body, amount of energy absorbed, some amount of energy absorbed, some reflected, some transmitted, and amount of energy absorbed by a body divided by total radiation energy falling on it is called absorptive power, A lambda. Which radiation is absorbed depend upon nature of the surface. I told you that when sunlight falls on red flower, so it appears red because it absorbs all color and reflects red color only. So depend upon nature. Now I come to here important topic, black body. Black body. Actually, we are very familiar with black color. We are familiar with colors present in light, visible light. We see an object when light falls on the object, body reflects light and this reflected light enter our eye and we see the object. Then what is black body? The body which will be not visible to our eye. Why? Because it absorbs all colors. So, if a body absorbs all the radiation, falling on it, then the body is said to be black body. I wrote here all the radiation, not only heat radiation, visible light, ultraviolet और X-rays और gamma rays, कोई भी radiation हो, if body absorbs all those radiation, then it is called a black body. Actually, on our surface, there is no perfect black body. Practically, there is no perfectly black body. The lamp S. I think you understand this. What is black? When you use a lamp which burn kerosene oil or any other oil, then it gives a dark S. So that is called lamp S. So lamp S is supposed to be 99% black. In the universe, there are black holes. Those black holes are nothing but they are dead stars. Their gravity is very high. So whatsoever fall on that absorbable light cannot be reflected back. Light unable to escape from that. So that black holes in the universe are perfectly black body. I told you that black bodies are those which we can't see. Then how the presence of black holes in the universe is detected? That is detected because of large gravitational pull. Because of large gravity, we can check or we can observe. So, but for practical purpose, I think you understand black hole. The student now knows what is black hole. The stars whose mass nearly 2.5 times that of sun, when they die, they form black hole. That means when total amount of energy emitted by that becomes zero. Every star keep on emitting energy because of nuclear fusion taking place inside. when total fuel get exhausted, nuclear fusion stops, and there are many steps in the death of a star. But those stars whose mass more than 2.5 times that of sun, when they die, they form black hole. And why they are called black? Because they are not visible. Whatsoever light fall on it is absorbed. It is very important to understand what is black hole and what is black body. Now, for practical purpose, Fairy designed a black body. This is simply a hollow sphere, hollow metallic sphere, having a narrow hole. As shown in figure below. Actually, here is a sphere, have thick wall and rough from inside, and there is cone type structure here, so that light does not fall normally. Radiation enters this hole, through this hole, a part gets absorbed here, then the remaining after reflection gets absorbed here. So due to multiple reflection, the radiation entered in the sphere gets absorbed. So it absorbs all radiation falling inside this. So we can treat it as black body. Now when this body is heated, it emits all radiation. Okay, and this hole is also called cavity. So when there is a cavity somewhere and that whole body is at high temperature, then radiation coming from inside are having large intensity and give us more energy, large amount of energy. For example, if you make your vehicle like car stand in the sun in a hot summer, when you open the window, sufficient heat energy come out which you can't tolerate. That is also due to this same reason, that they are radiation coming from car behave like this black body radiation, cavity radiation. Cavity means hole. So this was all about black body. Now I come to an important law. Actually, in NCERT book and syllabus, NCERT book has not any mention about Kirchhoffs Law. So perhaps given in the last, Kirchhoffs Law. Kirchhoffs Law. This law is about the emissive power and absorptive power of different bodies which are kept at same temperature. So according to this law, I write first and we prove. According to this law, the ratio of spectral emissive power to spectral absorptive power absorptive power spectral absorptive power. According to the law, the ratio of spectral emissive power to spectral absorptive power of all the bodies at which are kept in an environment at constant temperature is the same and is equal to the emissive power of black body. I told you here spectral radiancy, spectral emissive power, also called as spectral radiancy, to have spectral absorptive power. I told you a body, this is the only black body which can absorb all radiation, and other bodies have selective absorption. This green board absorb all colors but reflect green color. White cloth reflect all color, absorb नहीं करता. Black body absorb all radiation. So that is why I told you ratio of spectral emissive power. And mathematically we can write E lambda upon A lambda of body 1 is equal to E lambda upon A lambda of body 2 is equal to E lambda upon A lambda of body 3, so on, is equal to capital E lambda. Capital E lambda is the emissive power of black body. Condition क्या है कि all these bodies along with black body all should be at same temperature. These all bodies should be at same temperature. So according to this law, emissive power, spectral emissive power divided by absorptive power of all bodies which are at same temperature is the same and equal to the emissive power of black body at that temperature. Black body, I told you that which absorb radiation, but when it is heated and on cooling, the hot body also emit all radiation within range. Black body also. I will prove Kirchhoffs Law in next video actually. Otherwise, we will longer and keep and tell you something more about this.